Hey, welcome back to Math with Patrick. It's March 18th. We have problem number 78 from this Daily Epsilon calendar. We're going to try to solve it together. So x is the largest integer such that 1 through 37 can be partitioned into x subsets, all with the same sum. Okay, let's see. 1 through 37. I believe this problem is saying we have all of these integers 1, 2, 3, 4, all the way up to 37. And we need to partition or place into different sets. We need to partition these numbers into some subsets. So I feel like the easiest way to think about what a subset might look like is, well, what happens if x is 1? Oh, look who just joined us. There he is. Okay. If x is 1, it's a little silly. I'm partitioning this whole set into just one subset. And that basically means I'm piling all the numbers 1 through 37 into this set right here. So I really only have one set, but all one of my sets have the same sum. So this works. I might figure out what that sum is later, or why not? Let's do it quickly right now. There's a formula for this, n times n plus 1 over 2. And so since my n is 37, this formula works. And how about let's do 37 times 19. There we go, because that's half of 38. 9 times 7 is 63. I guess I could just calculator this, but I'm already halfway through the multiplication, so why not? Looks like we get this number, whatever this is, 703. All right. So that was kind of the trivial case, was just divvying it up into, well, not divvying it up at all, and just getting one subset. Okay. So I guess this is an important number, though, is figuring out that adding up all these numbers together gives you 703. Because now if I have x different subsets all with the same sum, I'm essentially just trying to factor 703. Because if x equals 2, then I'd have two different subsets, and I could throw 1, 2, 3 in here, then 4 and 5 over here, then 6 and 7. I could just kind of throw whatever numbers I want in these two sets. But their sums would have to be, if they're the same, 351.5 and 351.5. And since the objects in my sets are integers, they're whole numbers, this is not possible. I can't have 0.5 of something when I only have whole numbers. So effectively, I just need to factor 703. And once I do so, I will just try to find the largest factor, and that will be my x. So let's just check some divisibility rules. So 703 divided by 2. Actually, it's the other way around. This notation here asks does 2 divide 703? And it doesn't, because it's not an even number. And if we want to see if 3 divides 703, well, that doesn't either. If you add the digits of a number and you get a multiple of 3, then you can divide it by 3. But since 10 itself isn't a multiple of 3, I know that 703 is not either. I don't need to check the number 4 because I already checked the number 2. 5 doesn't divide 703. That's just because 703 does not end in a 0 or a 5. And, well, that's all the easy primes. Don't have to check 6 because it's even. Let's check 7. Well, fortunately, this one's actually pretty easy. You can see that 7 evenly divides 700, but then 703 won't work. So I'll just kind of put my thinking over here. 7 does divide 700, but it won't divide 703. Okay, don't need to check 8. Don't need to check 9 because we already know it's not divisible by 3. 10, and essentially any composite numbers you don't have to check here. So 10, 11. 11's the next one. And then this is going to be a little bit weird with all these vertical bars next to each other, but I think that makes sense. Let's try to find the nearest multiple. If I do, let's see, 11, or let's see, 10 times 70 is going to be 700. So 11 times something a little bit above 60. Let's do like 63 times 11. It's going to be 63 plus 630. Okay, a little too low. If I do 64, then I'll replace these with 64s. And this feels just like the right number to demonstrate why 11 doesn't work. 4, and then 0. There we go. So I just basically figured out that 64 times 11 is 704. And that means that 703 is 1 too short to be a multiple of 11. So I'll just write that here. 64 times 11 equals 704. All right. Well, onward to the next prime number. Let's try 13. Does 13 divide 703? Gosh, this is going to take a little while. So I guess how about let me skip until I find the next prime that works. 13 didn't work, 17 didn't work, 19 does work. And so if I find 19 times something equals 703, I will get all the factors of 703. I believe it's 37. Let me just double check over here. 37 times 19. Well, actually, it'll be a little bit easier in my mind to do 37 times 20, and then just take away one of the 37s. So 37 times 2 is going to be 74. So 37 times 20 is 740. And then I'll just take away one of those 37s, and I'll get 703. Okay, so I now know that 19 does divide 703. And let me amend my statement from earlier. I asked, what is the largest factor of 703? And kind of looking at the answer, because it's today's date, 19, this was actually a wrong question to ask. I wasn't actually trying to find the largest factor of 703. Basically, I just wanted to find a factor of 703. And what does this tell me? This tells me I could potentially split up all of those numbers 1 through 37 into 19 different sets. And each of those sets is going to have the same sum, and the sum will be 37. So let's see if this actually works. So if x is 19, that's my answer. And so I need 19 different sets, and they're each going to have the sum of 37. So, well, clearly the number 37 itself must be in a set, and it's not going to have a buddy, because if I put any of the other numbers in there, that sum will be higher than 37. Then counting down to 36, well, the sum isn't 37 yet, and there's only one number out there that I could put in the set to match it to the first one. So both of these sets have a sum of 37, and maybe you see where this is going. Basically, all of these pairs of numbers will sum up to 37, and we're gonna, let's see, what would the middle two numbers be? Half of 36 is 18, so I think we're gonna have 19 and then 18. And you can kind of see that these ones digits count up how many sets we have over here. So there's going to be 18 sets in this long list. And then if you tack on this guy right here, this one set, plus these 18 sets, we're going to have 19, which is the number x that we found earlier. It's also the date today. And so it looks like we can partition all of these numbers into 19 sets. They're all going to have the same sum, which is 37. And there isn't really anything else that you could do here, because there are no other factors of 703 besides 19 and 37. And if you tried imagining what would it look like if you tried doing 37 different sets, well, that would just be all the numbers being lonely each in their own individual set. And now you can kind of see that they're not going to have the same sum. So there we go. You can partition these numbers into 19 sets. They're all going to have the same sum of 37. So thanks for finding the solution with me, and I'll see you tomorrow. Bye.